Hello everyone, I am Vehan Vital and I am a final year undergraduate student at the Informatics Institute of Technology in Sri Lanka. I am excited to share with you today about my final year project Greenify Sri Lankan Rubber Diseases Detection System. First, I will provide an overview of the problem background and the challenges faced by the Sri Lankan rubber industry. Next, I will discuss the research gap and how we identified the need of an innovative solution to address the limitations of the traditional method of disease detection. After that, I will showcase the proposed solution and how it leveraged the power of convolutional neural network to analyze images of rubber leaves and trunk. Next, I will also demonstrate the user-friendly interface we developed to make it use for farmers to access the system and receive disease detection results. And next, I will walk you throughout the demo of our app and show you how it can help farmers to improve disease management and prevent economic losses. Finally, I will highlight the contribution of our project to the body of knowledge in the field of the rubber diseases detection system. And the last, I will explain about the evaluation and future works of this system. So sit back, relax, and let's dive into the world of Greenify, Sri Lankan rubber diseases detection system. First, I will explain about the problem background. Rubber is an important cash crop in Sri Lanka, contributing significantly to the country's economy. However, rubber cultivation is threatened by several diseases that can cause several damage to the crop. Early detection of this disease is critical in preventing their spread and minimizing losses. The traditional method of disease detection involves visual inspection by trained experts. However, this process can be time consuming and subjective, leading to inaccurate diagnosis. To address this issue, I have developed a machine learning based system that can automatically detect common rubber diseases. Our system is designed to identify 3 leaf diseases and one root disease that affect to the rubber crops in Sri Lanka. Coronaspora leaf spot, oidium powder mildew, collectorium leaf fall and white rot disease. These diseases can cause significant damage to the crop, leading to reduced yield and economical losses. The machine learning algorithm that powers this system uses convolutional neural networks to analyze images of rubber leaves and trunk. It has been trained on a large dataset of images to accurately identify the different diseases. I have also incorporated a user-friendly interface that allows farmers to easily access the system and receive disease detection results. By using our system, farmers can quickly and accurately detect and diagnose rubber diseases, leading to timely intervention and management. This in turn can help prevent the spread of disease and minimize damage to the crop and improve overall yield and profitability. Next, I will explain about the research gap of our system. Identifying gaps in existing research is a crucial part of any research project. By identifying these gaps, researchers can determine where their work fits into the large body of the knowledge and make a meaningful contribution to their field. One effective way to identify gaps is by conducting a literature review, which involves systematically reviewing existing literature on a topic. By analyzing the literature, researchers can identify areas where previous research is lacking or where new research is needed. The support of an LR can also provide the foundation of developing research questions and hypotheses, as well as guiding the overall research design. The gap identified from the literature review is a significant one, as most of the research studies conducted in the field of rubber plant disease detection have focused on identify only one or two diseases only, and these studies have been carried out in countries other than Sri Lanka, like Myanmar, Malaysia. This lack of research on rubber plant diseases in Sri Lanka, particularly in the context of detecting multiple diseases, highlights the need of the development of a solution specific to the Sri Lankan context. Additionally, it is worth noting that some of the existing systems developed for rubber plant disease detection are web applications, which may not suitable for use in all contexts. A machine learning based solution such as the one developed in this project can be integrated into mobile or desktop application and deployed in areas where internet connectivity is limited or unreliable. Next, I will talk about the proposed solution. The proposed solution is to develop a machine learning based system that utilizes image processing techniques to accurately identify and classify four rubber diseases. The system will take input images of rubber leaves and trunk and use various image processing techniques such as segmentation, feature extraction, and classification to identify the disease type. The proposed system will use a convolutional neural network model, which is known to be effective in image classification tasks. To overcome the challenges of limited data availability, the system will use image augmentation techniques to increase the size of quality of the dataset. The system involves several components including data acquisition, data preprocessing, feature extraction, and disease classification. For data acquisition, images of leaves and trunk of rubber plant with known diseases will be collected from rubber plantations in Sri Lanka. The dataset will be pre-processed to remove low-quality images and resize them to a standard size. Feature extraction techniques will be used to extract meaningful features from the pre-processed images. These features will be fed into a machine learning algorithm for disease classification. The algorithm will be trained on the pre-processed dataset and validated using test dataset. The proposed solution will be evaluated using both quantitative and qualitative measures including accuracy, precision, recall, and F1 score. Additionally, the system will be tested with new unseen images to evaluate its generalizability. To better visualize the proposed solution, a concept map has been created. The concept map serves as a visual representation of the proposed solution for this research project. It outlines the various components involved, including technology approach, problem domain, symptomatology, and future works and methodologies. Each component has its own sets of subcomponents which are detailed in the map. The technology approach component highlights the various techniques that can be used in this project, including machine learning, image processing, and data augmentation. These techniques are essential for accurately identifying and classifying the four different rubber plant diseases. The problem domain component represents the wide range of factors that can affect the health and well-being of rubber plants, including environment conditions, fungal infects, and insect infectors. The symptomology components outline the valuable symptoms that can be used for disease classification. such as leaf discoloration and trunk rot. Finally, the future works and methodologies component highlights the importance of continued research in this field, particularly in the areas of data collection and model refinement. By addressing these issues, the proposed solution has the potential to significantly improve the detection and management of rubber plant diseases in Sri Lanka. Now I will show the demo of the mobile application. This is the welcome screen of Greenify mobile application. If you click let's start button, it goes to another screen. It has two buttons which are analyze a leaf and analyze a trunk. If we click analyze a leaf, we can predict a leaf disease. If we click trunk, we can get a trunk predicted trunk image. In this window, we can click upload an image, and we can upload the image. Then upload the image will display here, and let's start analysis. Yeah, this is the predicted disease. The disease name is Ovidium. We can analyze again. If we click this name, we can see the disease name. If we click the analyze again button, we can predict another leaf disease. Let's try again. Let's upload another image. Now let's start analyze. Yeah, the disease of the image will show here. Now let's analyze again, but now let's go for analyze a trunk. Same as the flow of leaf image. Let's upload an trunk image. The uploaded image you will see here. Let's start analyze. Yeah, it's a unhealthy trunk. It means it has white root disease. Let's analyze once again. Analyze trunk, upload image. Now let's enter the image. Images will appear here. Now let's start analyze. Yeah, it's a healthy trunk. It means it doesn't have white root disease. Yeah, that's it. Now let's talk about the contribution to body of knowledge. This project has made a significant contribution to the body of knowledge in the field of rubber disease detection. By developing a machine learning based approach to detect and predict rubber diseases using image classification techniques, this project has proposed an innovative solution that can improve the accuracy and effectiveness of these diagnoses. Through extensive experiments and testing, the limitations of traditional methods of disease detection have been identified, and an alternative approach that leverages of the power of machine learning has been proposed. Additionally, this project has contributed to the development of new techniques for machine learning based disease detection, which can have applications beyond the rubber industry. The concept of using convolutional neural networks to analyze images for disease detection can be applied to other crops and even human health. Now let's move to the challenges. First one is a lack of image dataset. The lack of public data set on rubber diseases posed a significant challenge for this study. To address this issue, a dataset was requested from a previous researchers. However, one of dataset had problem with its quality and insufficient images, which hindered the accuracy of disease detection. As a solution, uh, additional image pre-processing techniques and data augmentations were employed to enhance the dataset's quality and quantity. Despite these difficulties, the research project was completely successful, overcoming the challenges faced during the dataset preparation phase. The second one is limited time. Meeting deadline is crucial in research projects as it ensures the project is completed within the designated time frame. Effective time management is a key to component of meeting deadlines and involves carefully planning and allocation of time to specific tasks. In the case of this project, there were multiple tasks that required completion within limited amount of time, such as data collection, model development, and evaluation. In addition to time management, it is important to maintain focus on productivity throughout the project to ensure that tasks are completed efficiently. This can be achieved through techniques such as setting achievable goals, minimizing distractions, and taking breaks when necessary to avoid burnout. To ensure that these tasks were completed on time, I have developed a detailed schedule and allocated specific time slots for each task. This allowed me to monitor progress and ensure that I was on track to meet the deadline. The last one is lack of domain knowledge. Lack of domain knowledge can hinder development of accurate and effective models for disease detection. In the case of rubber disease detection, understanding the various types of diseases, their symptoms and the conditions and in which they occur is crucial for developing a robust and effective model. Without this knowledge, it may be challenging to accurately identify and classify diseases, leading to positive or negatives. Moreover, a lack of domain knowledge can lead to the use of incorrect features or data for model training, which can affect the model's accuracy and performance. Therefore, it is essential to collaborate with domain experts and obtain their input to ensure the model's effectiveness and accuracy. By developing with domain specialists, researchers can develop a better understanding of the problem domain and identify critical features for disease detection, resulting in more effective modeling. Now let's talk about the evaluation and future works of this project. In addition to the input from domains and technical experts, the evaluation section also involved testing the system on dataset separate from the training dataset. This was done by determining the system accuracy and effectiveness in detecting rubber diseases on previous unseen data. Furthermore, the evaluation section also included a comparison of the proposed solution with existing systems. The results of the comparison showed that the proposed system was more accurate in identifying rubber plant diseases compared to existing symptoms. This demonstrates the potentials of the proposed system to be a valuable tool for rubber plantations owners and researchers in Sri Lanka, as it can accurately, effectively detect diseases in rubber plants. Overall, the evaluation section was crucial in determining the effectiveness of proposed solution in detecting rubber plants. The feedback from domain and technical experts as well as testing and comparison with existing system help to refine and improve the system accuracy and efficiency, making it a valuable contribution to the field of rubber plant diseases. Moving on to the future works, there are several areas that can be improved upon in the rubber diseases detection system. One potential area of improvement is to enhance the system ability to detect other diseases beyond the four currently identified. This would be require gathering additional data and refining the model learning algorithms used in the system. Another possible future work is upgrading the dataset used to train a model. Upgrading the dataset used to train the model is another important area that could be considered for future work. While the dataset utilized this study was sufficient for training the machine learning model, the inclusion of a larger and more diverse dataset could enhance the model accuracy and generalizability. In addition, the conclusion of data from different regions and under different environment conditions like background could lead to a more robust model that accurately predict diseases under a range condition. Therefore, obtaining larger and more diverse dataset can be a crucial step in improving the accuracy of the model for detecting rubber diseases. This could involve collecting images from a wide range of sources or obtaining more data from the same source to expand the existing dataset. Contacting specialists can lead to more accurate and reliable predictions. This is the another one good future enhancements can be done to the system. Experts in the field of rubber plant diseases have a wealth of knowledge and experience that can be invaluable in developing effectively machine learning models. Through collaboration with specialist researchers, can gain a deeper understanding of the complex nature of diseases and their unique characteristics. This in turn can help improve the accuracy and effectively of the developed model. Additionally, the specialist may have access to unique dataset and tools that can further enhance the model performance. Finally, another area of future improvement is identify the stage of diseases. Certainly, currently the system is only capable of identifying whether a plant is infected or not. By incorporating additional features to identify the stage of disease, the system can provide more specific and targeted solution for disease management. I would like to take this opportunity to express my sincere gratitude to my supervisor who provided valuable guidance and support throughout the project. I would also like to thank the Rubber Research Institute of Sri Lanka for their collaboration and expertise, which were invaluable in developing the rubber diseases detection system. Additionally, I would like to express my thanks to the domain and technical experts who provided valuable feedbacks during this evaluation stage. Finally, I would like to thank my family and friends for their unwavering support and encouragement throughout the project. Without their support, this project would not have been possible. And this is the end of my video. Thanks for watching.